All right, we just got that under. All right, let's do this. What was the last thing we were talking about? We were saying we want to do the inverse of 0. All right, think of 0. 0 is like 0 over anything, right? We'll just say 1. 0 over 1. What's the inverse of 0 over 1? It's 1 over 0, isn't it? Well, what's 1 over 0? It's undefined, isn't it? All right, we talked about that yesterday with the tangent. So, wow, what do you think? These inverse functions are going to kind of look like, what do you think? Like a tangent, exactly right. Let's do something, I just want to show you. Does it just go to 2 and stop? Let's put something like really close to 90. All right, let's go like 89 degrees. All right, somebody punch that in. I have no idea what that is at the top of my head. What's the cosine of 89 degrees? Right. It's point? Oh, I'm sorry. Yeah, you're right. What is it? 0.017. Okay. Now just take that. You probably have a button on the calculator that just says 1 over x. Do you see that somewhere on there? Okay. Keep that, big number in there. Hit that button right there, the 1 over x button. It'll take the inverse of it and give me a number. 57. Okay, I thought I remembered that from yesterday. Okay. So watch. The secant at 89 degrees is 57. So watch. What happens? It starts out, it goes 1, 1.2, 1.4, 2. Now we really skipped up a lot, didn't we? We went from 60 to 89, but look what it did. It went to 57. What if we put like 89.9? Then it would go really huge, wouldn't it? Okay, 89.99999, it would be really, really big. So what's it doing? It's approaching, all right, as it approaches 90, it gets higher and higher and higher and higher. That's kind of like the tangent was. Would you agree? So what we're going to do is this. Let's put some points in here. This is the cosine right here. Let me erase some of this stuff at the top. Get rid of this. Give me some room to write. Okay. And now, let's write. And let's do this. Let's do secant. This is already the cosine. It's already on the graph. So now let's do the secant. At 0 degrees, so right here, where do we put a dot? We put it at 1. Right? Well, that's the same spot as the cosine. So far, so good, right? But after that, it changes, doesn't it? At 30 degrees. At 30 degrees, where do we put it? At 1.2, which would be, I don't know, I'm eyeballing it about right there. At 45 degrees, which would be in between these two, I'm going to go to 1.4. So it's just a little bit bigger than 1.2. Maybe 1.2 should have been about right there, I guess. Does that make sense? Sorry for the 2 dots there. Let's keep going. What about 60 degrees? 60 degrees would put you at 2. Right there. Now, as I get closer and closer and closer to 90, what's happening to these points? They're going up, 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 like this, right? Until you get to 90. What happens when you get to 90? Do you get any value at all for the secant at 90 degrees? No. So guess what we put here? Remember this from the tangent? Asymptote. Okay? It sounds weird putting that P in there, but I guess that's how you pronounce it. So it's the asymptote. That's where you put the dotted line. That's where it doesn't exist. So there is no secant. There is no inverse cosine at 90 degrees. And that's what the dotted line stands for. Do you see that? So, I'm using that bottom dot right there. So if I graph it, it would look something, whoops, like this. See, it gets really, really close. But it'll never, ever touch. As long as I don't hit 90. If I get closer and closer to 90, it doesn't matter how close I get, this thing will continue on up, 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 up. Okay? Now remember I said I'm not going to fill in the rest of them? This is why, because the other side's just a mirror image of this. Okay? They're symmetric to each other. So look, I went over 90 this way and put it the asymptote. What do you think I'm going to do for this? This should be familiar because we did it. Okay, because look, see this dot right there? The cosine at 90 degrees is 0. So the secant is the inverse of that, so it's going to be undefined. Look at this. The cosine of negative 90 is 0, so guess what? The inverse of that's going to be what? It's going to be undefined. Very good. All right, so I can put an asymptote right here. Put the dotted line. Not the straightest dotted line in the world, but that's okay. Let's keep going. That's good enough. All right. Now, what do you think it's going to do over here? It's going to basically follow the same exact pattern, isn't it? It's just kind of going the other direction. So if you wanted to, look, this went 31.2, so this is going to go negative 31.2, so about right here. This went 45.1.4, this is going to go negative 45.1.4. This went 60 degrees then 2, so this is going to go negative 60 degrees then 2. You get it? And so it just kind of follows like that. All right? So that's basically what it looks like. Now, what do you think it does down here? Now watch, every 180 degrees. Do you see that? From negative 90 to 90, that's the period of this thing. Actually, it's not. I'm sorry, it's not, because on the tangent it is. Let's see what it does over here. But every 180 degrees, we are going to put an asymptote. Watch this. From negative 90 to 90, that's 180 degrees. Now, where's our next asymptote? Our asymptote is where the cosine was 0. Do you see it? Every time the cosine was 0, the secant is going to be undefined. So let's just draw these in real quick. And you get the idea for the rest of it. So let's see what we do. Look, we put a point here and we went up. But what do you think you're going to do here? You're going to put a point here and go up like this? What's your gut reaction here? It's going to go down, exactly right. So I don't have to be real perfect and put every single little dot in there. I can just know where it's going to bottom out at negative 1, and it's going to go down like this. And it's going to go towards the asymptotes, but it'll never hit them. And it'll go like that. Now that's one period. That's one full rotation. Then guess what it's going to do here? It's going to hit here, and it's going to go up like this. Down here, it's going to go down like this. Every time it's on one of those down curves, it's going to go down. Every time it's up at the top of one of these, it's going to go up. So you definitely see a relationship between the secant and the cosine, don't you? When you actually have to graph the secant, what I do is I plot the points for the cosine, tell you the truth, because those are key points right there. Because when the cosine is 0, the secant is undefined. When the cosine is 1, that's where it starts going up. When the cosine is negative 1, that's where it starts going down. Does that make sense? So those are the key points. Once you realize the shape of it, what it's supposed to look like, you don't have to put every single one of these little points in here. We just did that to show you the first time. All right? After this, you just kind of have an idea what it's going to look like. You just have to study it and go back and say, okay, this is the secant, this is the cosine. And look, the sine does the same thing. I'm not going to go through all this mess to show you the sine. I already programmed it into the computer, and we're going to see what it looks like. All right, but I don't have to go through all this mess right here. So let's do this. Let's keep that up there, all my writing. And let's put in what the, see now, this program, it doesn't let you put secant in there, so I just put 1 over the, 1 over the cosine, okay? So, and I made them both green so you can see the ones that went together, right? Wasn't that smart of me? All right, there it is. Wow, look at that. That wasn't too bad. I mean, it curved up a little quicker than what I did right here, but it's basically the same idea. That was pretty bad. That should have humped over a little bit more steep like that. But you get, it's still basically the same thing, isn't it? Let's get rid of all this mess. All right, now that looks a little better. Now check it out. This wavy one right here is the cosine, and this one is the secant. All right, you can definitely see the relationship between them. We can blow it up like this, right, and it just keeps on, right, just keeps on going. You see that? At every top point it goes up, at every bottom point it goes down. Again, what was the period of this thing? It was 360, right? Now the tangent, what was the period of the tangent? It was only 180, okay, because it repeated the same thing every time at every 180 degrees. This time it repeats the same pattern. Let's blow it up a little bit, watch. So you got it up, you got it down, within how many degrees? From negative 90 all the way to where? 270. Negative 90 and 270 is 360 degrees, isn't it? From negative 90 to 270. So the period is 360 degrees. We good with that? All right.